Okay. This will be my attempt to try to go to this review as quickly as possible so that it doesn't become a very long video. I have already worked out each one of these examples, but I wanted to talk about how my process of thinking as I went ahead and solved each one of these problems. So let's go ahead and get started. In example number one, or question number one, it seems like we need to identify the pattern and we need to find the next term or whatever term is missing. I noticed that from 2, 4, 8, 16, and 32, I recognize that to get the next number, we were always multiplying by 2. So therefore, in order to get the next number, I took the number 32, multiplied it by 2, and that's where I got 64. For example number 2, it seems like we're doing a computation and we would like to use our rounding techniques that we talked about at the beginning of class. And then we also want to find the exact sum and then look at the difference. Well, when I look at the estimate, I went ahead and rounded each one of these numbers. So notice that for 9.6868, I rounded that to 10. For the number 1.22, that rounded out to 1. And then for the number 1731, that rounded up to 17. Adding those three numbers, I got 28. The actual sum, I computed it with the calculator and verified that it was 28.21. In this particular example, it is reasonable. The estimate is a little bit lower than the actual answer. In question 3, it talks about two individuals. One individual earns $70,000 per year, and another individual earns $4,750 per month. It wants to compare both individuals. Well, what I've done here is for individual B, I wanted to write this number in terms of how much money they make per year. Well, since they're making $4,750 a month, multiply that by 12, that's 12 months is 1 year. And so that came out to 57,000. The first person earns more than the second person. Well, how much more? I take a difference, and that answer is 13,000. For example number 4, we have a set that is described in this form. Understanding the symbols, it's saying that every element in this particular set belongs to the natural numbers. Well, what are the natural numbers? The natural numbers are 1, 2, 3, 4, and so on. In addition to being a natural number, it is also greater than 5, but less than or equal to 10. Well, what are the natural numbers that are greater than 5, 6, 7, 8, 9, and 10? But also we're stopping at exactly 10. Notice the use of inequality symbols here. Here it's stating us that this natural number will not be equal to 5. However, using this symbol right here, notice that little dash underneath the inequality symbol indicates that it has to be equal to, less than or equal to 10. In example number 5, it just wants to determine whether this statement is true or false. Again, we're saying, is this number, which is 18, is it a member of this set? Now, there are obviously some terms that are missing, but what I notice is that each one of these terms is an odd number, while the number 18 is an even number. Therefore, this element doesn't belong to this set, because here we are describing odd numbers while this number is even. In number 6, we see another set represented in this form. This represents the element, it's a natural number, and the number is less than or equal to 12 million. What does that look like? Well, it is a natural number, so it is 1 or 2, 3, 4, 5, so on, until the number 12 millions. We can actually count the number of terms in this particular set. So this set is finite. In example number 7, we're determining whether to use the subset symbol or the proper subset or both, or possibly neither. What we're doing at this point in time is we're comparing sets to sets. So no one, two sets. The set A is all the elements that belong to the natural numbers and are between 7 and 11. Well, the natural numbers that are between 7 and 11 are the numbers 8, 9, and 10. This is set A. Set B is the set of all natural numbers between 6 and 12. Those are 7, 8, 9, 10, and 11. The question is, A, is it a subset, proper subset of B? Well, in this case, it is a subset because we can find all the elements of A in B. It is also a proper subset because A is not necessarily equal to B. So therefore, we can use both, whether subset or proper subset. In example 8, they're giving us a set that has 3 elements: pineapple, strawberry, lemon. The cardinality of set, what I call A, is 3. There are 3 distinct elements within that set. So therefore, how many subsets are there? There are 2 to the 3 power, which makes it equal to 8. What is 2 to the 3rd power? It is 2 times 2 times 2. This is the only option here. Option C is the only option that has 8 distinct elements. All the other ones have less than 8. So therefore, all the subsets will be 8, and they're listed in answer choice C. In example 9, they're giving us a universal set. They're also giving us a set A. They want us to write the complement of A. I try to define it here. The complement of A will be all the elements in the universal set that are not in A. What I've done here is I've written set U, and I've crossed out the elements that belong to A. Well, if we delete E and I, we're left with the elements B, F, G, H, and J. In example 10, they want us to find this operation. What is this operation? That is the intersection of 2 sets. What does that mean? It means that we are going to compare both sets and write the elements that they share in common. I've done that here. The elements that A and B share in common are the elements 1 and 2. In number 11, they want us to use the Venn diagram to count the number of elements that will be in the union of A with B. In other words, they're telling us to put all the elements of A with all the elements of B without the need of repetition. That's why what I've done here is I count the number of pins that are in A and B. 2, 3, 4, 5. In this form, I have avoided double counting, and there must be only 5 elements in the union of A with B. In example 12, They want us to find a more complex set operation. They want us to find a union. They also want us to find a second union and then find an intersection. Notice that for this example, I've found the union of A with B, and I've also found the union of A with C. After finding those unions, I then found the intersection of these two sets. And again, the intersection is finding what they have in common. Notice that I've done that by saying 1 and 1, 2 and 2, 3 and 3, 4 and 4, 9 and 9. For those of you that didn't understand the union, when I talk about the union, I put all the elements of A together with the elements of B. There is no need for repetition. That's why you don't see the number 3 listed twice. So again, the union, which I need to do that here and here first before we find the intersection. We took all the elements of A, put them together with all the elements of B without the need of repetition. Took all the elements of A, put them together with the with the elements in C without the need of repetition. Once we had that, we then look for which elements did this set and this set have in common. Number 13. They want us to find another operations with set. Notice that in this case, it seems like we have a slightly simpler example than the one before. However, we must find this intersection first. That's what I've done here. And in this case, I've shown that the only element that they have in common is the element A. And then they want us to go ahead and take whatever we found here and put it together with with A. Well, if we add the letter A to this set, we get A, B, G, and H. This is an application problem. Trying to summarize this, it says use the Venn diagram to represent the set of students who score 80% or above on exam 1, not on exam 3 in roster form. So I try to highlight this so that it can make it a little bit easier. Here in this case, you notice that I've highlighted the names of the students that earn an 80 or above on exam 1. But why did I exclude male? Excluded male because male, although they belongs to exam 1, also belongs to exam 3 and 2, which is not relevant in this case, but male belongs to exam 3. And therefore, male should not be included because we do not want to include male because it's in exam 3. So in this case, we have Gus, Eva, and Huey. On number 15, we have another application problem. It says that there was a survey with 120 students. Of those that were surveyed, 34 got the news from websites, 47 from social media, and 19 from both platforms. It says to construct a Venn diagram and then answer some questions. In the Venn diagram, we notice that there is an overlap between the two sets. The set of students that get their news from the website, and the set of students that get their news from social media. I started with writing the number 19 here, indicating that 19 students get their news from websites and social media. Then, if you're wondering where I got the 15 from, well, it is 34. So therefore, 34 minus the 19 that are already here leaves us with 15 students that only get their news from websites. Where is this 28 coming from? Well, 47 students get their news from social media. 19 taken from 40, or take 19 from 47, that leaves with 28 students that only get their news from social media. What about this 62? Or let me take that back. Yeah, where about this 62? What is the relationship with this 58? Well, there is 120 students in total. If we add these students, 15, 19, 28, okay, we get 62. Either they get it from here or here. So adding these three numbers, we get 62. If we now look at this 58, that will be the number of students that do not get their news from neither this set nor that set. 128 minus this 62 gives 58. Number 16. Number 6, starting from 16 on, we begin to talk about logic. So from the next set of questions, we talk about chapter 3, logic. And so it says express the quantified statement in an equivalent way, and then write the negation of the quantified statement. A quantified statement will be of the form of something that looks like these 4 types. All A are B, some A are B, no A are B, some A are not B. And I also written what will be the equivalent quantified statement. So the equivalent statement to all A are B will be to say no A are not B. Some A are B, the equivalent form will be at least one A is B. No A are B is equivalent to all A are not B. Some A are not B is equivalent to not all A are B. So now you're wondering, well, you got a whole bunch of circles. What does that mean? Well, after I written this out, I then look at what type of quantified statement was presented in example 16. In this case, it says, there are no computers that are not smart. In other words, this is of the form of no A are not B. Again, let's read that one more time. There are no computers that are not smart. That is of the form no A are not B. The equivalent to that is to say all computers are smart. And that's what I've highlighted here and pointed to the right answer. What is the negation? Well, since we have all computers are smart, all A are B, its negation is some computers are not smart. The negation of all A are B is some A are not B. The negation of no A are B is some A are B. But in this particular case, the quantified statement was of the form all A are B, so its negation is some A are not B. Question 17. We have two simple statements, P and Q. P, I work hard. Q, it is snowing outside. It wants us to write this symbolic statement in words. Notice that I've highlighted the V looking symbol. What that means is that this will be replaced with the word or. For the simple statement Q, there is that squiggly notation, which is the negation of Q. All I'm going to do in this case is introduce the word not. So therefore, not Q reads, it is not snowing outside. Putting things together, we have, it is not snowing outside, or I work hard. We have P, Q, and R. P, the chair is broken. Q, I study. R, the job pays well. We have a written statement and we would like to write it in symbolic form. If the chair is broken or I do not study, then the job pays well. Notice that this is an if then statement. It is a conditional. And the first part of the conditional is highlighted here as the chair is broken or I do not study. Because this statement is before the comma, it must go inside of parentheses. It must be grouped. So notice that when I wrote it, I have parentheses. We have the chair is broken, that is P, or is the V looking symbol. I do not study is the negation of Q, then R. For number 19, we have two statements, P and Q. They want us to determine the truth value of P or not Q. Before I answer this particular example, I want to direct your attention here to the definition of or. Or is a disjunction statement, and it is only true as long as there is a truth, there is some truth in this statement. We notice that P is false. Why? 10 plus is not 13. While 4 times 8 is 32. So P is false while Q is true. So we wrote down the symbolic representation. We have false or not true, false or negating a true statement makes it false. We have false or false. There is nothing true about this statement, so therefore the disjunction must be false. In example number 20, we are constructing a truth table. Okay. So what I will recommend each one of us is to work a column rather than by row. Okay. So once you to complete the column for not P, notice that is the opposite of P. True, here is false. True, and here's false. False, and here's true. False, and here's true. It wants us to put P and Q together with connective or. Once again, I mentioned that the or statement is only false when, or well, is true as long as you have some truth in the statement. So therefore, true, 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 true or false, true, false or true must be true, but false or false is always false. Then it wants us to connect this column with this column using the connective and. And the connective and only true when both of the components are true. So that's why when you look at this column and this column, true, false, that will be false. True, false, that will be false. True and true is true. But false and true is false. Question number 21 is slightly more difficult because it is giving us three variables. Notice that when we have three variables, now we have 8 rows. Luckily, P, Q, and R are already completed. They want us to go ahead and, well, actually, I think these are already the answers. But these first three columns are already completed. But what I what I think is challenging here is understanding the direction because it matters on a conditional. Okay, I see that little arrow must be a conditional. And I'm telling you here that a conditional is only false when true value is followed by a false. Then that statement will be false. So if you have true, then false, then the statement will be false. And so in here, I am trying to indicate the direction because the direction matters in a conditional. These are the values for this disjunction. Notice that we're going, if true, then true, that must be true. The only one that I'm looking out for is true, then false. True, then false is false. True, then true, true. Once again, look out here. True, then a false must be false. True, then true is true. True, then false will always be false. But in this case, false, then true, that is true. Okay, look at the order. It is first the false, then the truth, that must be true. False, then false, that will be true. The only time a conditional is false is when it is in this exact order. True, then a false. For example, here, true, then the false. That will be false. In number 22, it wants us to determine whether this particular statement is a tautology, a self-contradiction, or neither. What I've done is I've given some definitions as to what a self-contradiction looks like. That is, all the outcomes are false. Tautology is when all the outcomes are true. In this particular case, I thought that it would be best to create those additional values for not P and not Q. And that's what you see here, because maybe in this particular case, it might have been a little bit too quick for our understanding. Okay, so I've deliberately written these columns, even though they're not part of the actual truth table that was provided by MyMathLab. So notice that they wanted us to put together not P and Q. So I thought it was important to have the not P column present so that we do not make any mistakes. In any case, when we are connecting two things with an and, in order for that to be true, both of the components need to be true. So we have a false and a true, that will be false. We have a false and a false, that will be false. But notice here we have true and true. That is the only time an and conjunction will be true. Here we have true, but false, that will be false. Then we are connecting P with not Q using the connective or. Once again, or as long as you're telling the truth somewhere, the statement will be true. So true and false is true because something is true. True and true will be true, but false and false will be false. False or true will be true. And then we connect these two columns using once again the connector and. And again, and is only true when both of the components are true. So this will yield false, 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 false. All the outcomes of this column are false, so it must be a self-contradiction. 23. They want us to write the converse, the inverse, and the contrapositive. So what I've done is I'm giving you what a conditional looks like. If P, then Q. I gave the definition of what a converse, inverse, and a contrapositive look like of a conditional. Converse in which is when we swap the order. Q is now first and P is second. Inverse, we keep the same order, but we negate both first and the second part. In the contrapositive, we are swapping the order and also negating at the same time. So if not Q, then not P. So they're giving us a conditional statement. If Australia is not an island, then Mexico is an island. It wants us to choose the converse. So we are swapping the order. Mexico is an island, then Australia is not an island. The inverse of the conditional. The inverse of the conditional. If Australia is an island, then Mexico is not an island. And then lastly, it wants us to find the contrapositive, this conditional. So we are going to swap the order. So it will read, if Mexico is not an island, then Australia is an island. Okay, so just make sure that you look at the definitions that I provided here or something like example number 23. 24, I noticed that we begin chapter 8, which was finances, personal finances. It begins by finding the percent of 7, to find a simple, straightforward percentage example. It is saying that actually my numbers look different than the ones here. In any case, my apologies for that, but this will be the same way that it will be worked out. What percent of 7.5 is 0.06? Well, notice that I'm writing that as 7.5 times the percent will be equal to 0.06. In solving this equation, we divide by 7.75 on both sides. So what we are doing on the calculator is 0.6 divided by 7.5 will be equal to 0.08, and then we convert 0.8 to percent. Okay. All right, moving on to 25. Wants to find the discount amount and then the sales price. So in this particular example, there is something whose original price 770 and is on sale for 24% off. Notice that in this case, 24% is equivalent to 0.24. then the discount amount is the multiplication of 770 with 0.24. That leads to 184.80. What is the sales price? Well, we take the difference between the original price and the discount price, and that turns out to be 585.20. Question number 26, we're talking about simple interest rate. So I highlighted that because that is important. There were formulas for simple interest and there were formulas for compounded interest. In this particular example, MATLAB is not providing us with any formulas. So I know that I am finding future value of simple interest given by this formula. Okay. The important thing about this formula is that A represents the future value, E is the present value, R is the annual interest rate, and T is time in years. So there's an initial investment of 8,000 at 7%. Notice that I'm in the formula is 0.07 for 6 years, and carrying out this computation on the calculator yields 11,360. As we're talking about money, 0 cents. Plus it says round to the nearest cent. So you want to write cents, even if it's a whole number, because the way MATLAB wants it, it wants cents. You give them cents, even if it's 00. For question 27, it wants us to find the effective annual yield. For this particular example, MATLAB is offering some formulas. Some are irrelevant to this example, and one of them is actually the one that we need to use. This is the formula for effective annual yield. They're giving us the annual interest rate. They're telling us what M is quarterly and equals 4. And that's all we need to plug in into the formula. 1 plus the interest rate divided by 4, all of that raised to the 4th power, all of that minus 1, and then that gives 0.0171. The effective annual yield is always given in percent. So therefore, here I am computing what that would look like in percent. Making this decimal into a percent, moving the decimal point 2 places to the right, then gives 1.71%. In example 28, once again, I've noticed that MATLAB is providing us with some formulas. Let's read the example so that way we know which formula is the appropriate formula for this example. It seems like at the birth of a child, a grandmother deposits $9,000 in an account that accrues 3% compounded monthly interest. What will be the value of the account at the child's 21st birthday? There are no additional deposits or withdrawals during this 21-year period. Because there are no additional deposits, this is not an annuity. This is just a future value example with compounded, and the appropriate formula for that is this one that I've highlighted here. Initial deposit is 9,000. The interest rate is 3% here in decimal form. It is compounded monthly, so that's why you see 12. This 21 years, all of this yields 16,885 rounded to the nearest dollar. Use your rounding, your proper rounding techniques for something like number 28. read the fine print on MyMATLAB. Do not make a silly mistake. Number 29, straightforward, wants to find the value of an annuity. But more importantly, MyMATLAB has provided some formulas. Which one is the right formula for this example? Well, how do I determine which one is it? Well, first of all, it wants to find the future value, so it must be either A, this formula, or this formula. This formula right here, the third formula, when you see the P, is because you're looking for what will be the periodic payment. Okay. Going back to what this needs to do, we need to find the value of the annuity, either this one or that one. Since the interest rate is compounded, it must be this example here. It is compounded quarterly and will be equal to 4. 6.75% is the interest rate. Time is 5 years. There is a periodic payment of 1,500. If you make payments every 3 months, you're going to end up making 4 payments in a year. This information is similar to this information, or it's the same. Okay, the interest is compounded 4 times a year. Here is saying that you're actually making 4 payments in a year. In any case, plug in the numbers in. I will recommend that you do this with your calculator. Make sure that you know how to use your calculator. This computation led to this value. Okay, so after 5 years, there is 35,333 rounded to the nearest dollar. Interest is the following. It's computed in the following way. We made contributions of 1,500 4 times a year for 5 years for a total contribution of 3,000. The value of the annuity is 35,333. So the difference between these two numbers equals the interest that was earned over the 5 years. Number 30. Suppose that you decide to buy a car for that particular price. You put a down payment. Put in the down payment will reduce the price of the car. Whatever is left over, you decide to get a loan for 4 years at 5.39%. It tells you what formula to use. It's not 26,635. Instead, it's 20,635 because you knock down 6,000 off the price. We're making monthly payments, so that's why n is equal to 12. Once again, make sure that you know how to use your calculator. It says round to the nearest cent, so therefore we see 478.86 after this computation. Total interest, like the example before, we make $478.86 payments every month, 12 months for 4 years, for a total of $22,985.28. This is how much we actually pay for the car. The price after the down payment was $20,635. So the difference between these two numbers is how much we ended up paying in interest, rounded to the nearest cent, 2,350. Number 31, once again, this question is telling us what formula to use. It is saying that there is the price of a home is 227,000. The bank requires a 20% down payment. So, in that case, 127,000 times 0.20, that is 45. Since we're paying that up front, we need to take that off the price of the home. So the difference between the price and the down payment is 181,600. The bank charges 3 points at closing. So we are financing 181,600. And so therefore we have to pay the bank 3 points. In other words, 3% of what we are financing, rounded to the nearest dollar. The bank gets 5,448. Again, tell us how to find the monthly payment. So we're using this formula. The amount that we are financing, the annual interest rate, divided by 12 because we're doing monthly payments. Computing this correctly in the calculator, rounded to the nearest dollar, is 1148. Once again, it wants to find the interest over the 30 years. Remember, we are making payments of 11,148 every month for 30 years. That total is 413,280. The price of the home was 181,600. The difference between these two numbers is how much was paid on interest. 32. Once again, I noticed that on 32, my MATLAB is telling us what formula to use. So therefore, in this case, we have a balance of 3,600, an annual interest rate of 18, and we want to pay it in 2 years, making monthly payments, pay each month. N is equal to 12, plug in all the numbers correctly, rounding to the nearest dollar, that gives you 180. Okay. Once again, it wants to find out the total interest paid over the 2 years. You're making $180 every month for 2 years. That total is 4,320 minus whatever we had at the beginning, the balance. And so therefore, the difference between these two numbers is 720. I noticed that that is the end of chapter 8. And chapter 30, in example 33, begin the conversations out of chapter 7. Okay. It begins with an example that says license plates in a particular state displayed followed by 3 numbers. That is 6 slots. One, first letter, second letter, third letter, and then the third number. Now, why do we find these numbers? Why is there a 26? So there are 26 letters in the alphabet. So for the first letter, there are 26 options. The second letter, there's also 26 options. For the third letter, there's also 26 options. But what about the 10? 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10 digits. So there are 10 digits available, and 10 digits available. Using the fundamental counting principle, the number of items in this group times 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 the number of items in this group. That gives an answer of 17,576,000. Yeah, that's it. All right, so that was using the fundamental counting principle. There were 6 slots. 3 letters, 3 digits. Number 34, it says that there is a camp counselor and 8 campers. That's a total of 9 people. They are to sit at a bench. In how many ways can this be done if the counselor must be seated in the middle and the camper that has a tendency to engage in food fights must sit to the counselor's immediate right or left? Apparently, I don't know my left from right, but it doesn't matter in this case whether this camper sits to the left or sits to the right. The counselor must be in the middle with the person that creates food fights right next to them. That gives the first 3 options are why 7? Well, because there's 8 campers, so that leaves 7 available for the first slot, 6 available for the second, 5 available for the third spot. Then the 6th spot, there will be 4 people available. 3, 2, 1. You get the idea. The number of ways that this can be done times the number of ways this can be done times the number of ways this can be done, blah, 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 blah. That yields the number 50/40. Okay. 35. Use formula for a permutation to evaluate the following thing. This can be done with the calculator. And you know how to use the calculator at this point in time. I am just showing you what it would look like to actually write down the work. Okay. We have 13 factorial divided by 13 minus 0 factorial. That will be 13 factorial over 13 factorial will just equals the number 1. Once again, this can be done with the calculator. An application problem reads, club with 16 members is to choose 3 officers, president, vice president, and secretary treasurer. Because we're choosing 3 people with titles, this must be a permutation. And so in how many ways can officers be filled? Well, we have 16 to choose from, and we're only choosing 3. We have already said that this is a permutation. This number can be evaluated using the calculator. Here is the math behind it. 16 factorial divided by 16 minus 3 factorial, which gives this number 3360. Number 37, it says to evaluate the number of combinations, something that can be done with the calculator. The number of combinations, if we have 25 things and we take 4 at a time. Here's the math behind it. I computed this number using the calculator. 38. 10 possible books you plan to take 8 on a vacation. Well, given that in this particular case, there is no sense of titles per se, so it doesn't matter the order in which the 8 are chosen. This must be a combination of 10 books, and we are only taking 8 at a time. This can be done with the calculator. Here is the math behind it. The result will be 45. We'll check with the calculator. Now we move to chapter 12, which begins with probability. Some very simple probability. You are dealt 1 card from the standard 52 card deck. Find the probability of being dealt a diamond. Well, where are these numbers coming from? There are 13 diamonds to choose from out of the 52. Simplifying this fraction leaves 1/4. There are 13 diamonds. There are 13 clubs. There are 13 hearts, and there are 13 spades. Okay. There's also 4 kings, 4 jacks, 4 queens, 4 aces, 4 twos. Okay. Blah, 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 blah. There are 26 red, 26 black. Just make sure that you're familiar with, somewhat of familiarity with a 52 card deck. 40. There is a spinner, and it seems like it was broken down into 8 sections. Some of them are red, some of them are blue, some of them are yellow, some of them are green. Find the probability that the pointer lands in a region that is green or red. Well, I looked at the spinner, and there is possibly no way for the spinner pin to land on a section that is green and red at the same time. It just won't work. So this must be mutually exclusive events. So in order to find the probability, I need to find the probability that the spinner will land on green. That is 2 out of the 8 possible options, plus the probability that it lands on red. Also 2 out of 8. When we add fractions, if they have the same denominator, which they do here, we add the numerator, so that becomes 4 over 8, which reduces to 1/2. Again, I am making the point that there is no way that the spinner can land on green and red at the same time. That cannot happen. So therefore, there must be a mutually exclusive event. So therefore, the probability of green or red is the probability of green plus the probability that it lands on red. 41. We saw a similar example like this in class where you have a bunch of people that are invited to a dinner party, and it seems like the order is important in which they arrive. Okay. So they will give different different arrangements. So we have 8 people that are invited, and how many ways can they arrive? Well, they can arrive in 8 factorial ways. There's 8 possibilities for the first person to arrive for the first person. After the first person arrived, that means only 7 can arrive second, 6 could arrive third, 5 that could arrive fourth, 4 that could arrive third, 3 that could arrive what is it? First, second, third, fourth, fifth, 6 people that could arrive 7, and then that leaves only 1 person that could arrive last. Okay. So therefore, in this particular case, this is the number of ways that it could be arranged in what is it, in a line. Okay. In any case, 4320 says that Sarah and Eduardo must be first and last. But what happens in the middle? Well, that means that since 2 people are already set, that means that 6 people are available to arrive second, 5 will be able to arrive third, 4 will be able to arrive fourth. You get the idea. This product is equal to 720. It says find the probability that Sarah will arrive first and Eduardo last. So therefore, using the previous numbers, that is 720 over 4320, which reduces to 1 over 56. I like this particular example. We did something like that in class. We saw it again in our chapter exam, and then we're seeing it again on the final exam. So we've seen this particular example multiple times. 42. There's a stem and leaf plot. There's 1 stem and 2 leaves. 1 leaves is about the actor's ages. The other leaf is actresses' ages. Okay. And so 0 corresponds to an actress, one actress that is 20 years old, 21. And for example, in this case, we have an actor whose age is 30. Let's see what kind of questions they're asking. What is the age of the youngest actor to win an award? So I am in this column, and the youngest actor is 30 years old. Question B. What is the age difference between the oldest and the youngest actress to win an award? Now we are here. The oldest is 83. The oldest actress is 83. The youngest actress is 20. 83 minus 20 will give us 63. What is the oldest age share by two actors? Two actors were here in an award. Well, we see 32, 32. That cannot be it. 57, 57. You see that? Okay. Although there were 32, 32, and it was also a 40, 40, 42, 42, 43, 43, 47, 47, 48, 48. The oldest is 57. Once again, another 57. That is the oldest age shared by two actors to win an award. Okay. And then it asks to kind of what differences do you observe in the two stem and leaf plots? What explanations can you offer? The only one here that could make sense is option C, but I'll let you read that on your own. 43, they're giving us a line plot, and they want us to find median, mean, median, mode, and mid-range. Okay. So notice that I took the line plot, and what they're saying is that this particular point here, notice that there's some dots, indicates that there's 2 10s, 3 11s, 5 12s, 6 13s, 3 14s, 1 15, and I wrote that list down. Okay. I counted there were 20 data items. That is important because if when I find the mean, okay, I need to divide by the number of items. There are 20. So here I try to be a little bit more short in my handwriting here. I noticed that there were 2 10s, so that was 2 10s plus 3 11s plus 5 12s, blah, 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 blah. Doing this computation gave me 12.4. I noticed that having the data arranged from lowest to highest allow me to find the median, which in this case, I'm highlighting that these two values will be the ones in the middle. So the median will be the average of those two values, which happens to be 12.5. Also, the mode, which could also be easily found by looking at the graph, notice that the data item 13 occurs the most, but I could also highlight it here as well. Okay. All right, and that should have been okay. And then the mid-range, okay, that will be in this particular case, I didn't write it down. Okay, that will be 15 plus 10 divided by 2. Okay. The mid-range is 15 plus 10 divided by 2. Finally, number 44, we want to find the standard deviation for this group of data items. There's 8 of them, okay? And luckily, it's only the numbers 16 and 20. The standard deviation is given by this formula here. But to find this, I believe is easier to create a table where we are showing the difference between the data item minus the mean, and then we square that quantity. This symbol says to add all these items that are square and then divide them by the number n minus 1, and then finally take the square root. Well, let's take this one piece at a time. Data item 16 minus the mean. Notice that the mean was found here to be 18. So that was done 4 times. Negative 2, negative 2, negative 2. Then 20 minus 18, that was every data item that the result was also 2. That was pretty simple. Negative 2 quantity squared, that's 4. That was going to happen 4 times. And then 2 square is also 4. That happens also 4 times. Adding this up, we get the number 32. So that's what you see here. Where is the 7 coming from? 8, because there's 8 data items. 8 minus 1 is 7. Taking the square root of that gave us 2.14, and that is the standard deviation. Okay, that's it for the going over the review. Hopefully this helps. Thank you. Bye-bye.